Okay, so first we're going to calibrate the pH meter, and we're going to get the node and we're going to wash it out, dry it off, and we're going to put it in the 7 pH buffer. We're going to hit the 7 in there, and then we're going to keep the data. So after we're done with this, we're going to wash it out again with our distilled water, and then we're going to dry it off, and we're going to stick it in the 4 pH buffer. And once we do that, we can hit 4 and we can keep it. So once we have that, we see that we have about a reading of 4 pH, and we can wash the node out again and store it in our distilled water.
Alright, I'm going to calibrate my pH meter. Going to press the red bar, calibrate now, start calibration. Okay, I'm going to put in 7. That'll be the first buffer I will use. I'm going to take the electrode out of the distilled water, then I'm going to dry it off. Okay, then I'm going to put the electrode in the buffer 7, swirl it, and as I'm swirling it, let the meter regulate, and then I'm going to press keep. Okay, for the next step of the calibration, I'm going to put in 4 for buffer 4. I'm going to clean the electrode with distilled water, dry it off, and then I'm going to put the electrode in buffer 4. Okay, I'm going to wait for it to regulate, swirl, and then I'm going to press keep. Okay, now I'm going to press OK. It should be now regulated, and I'm going to wash the electrode off with distilled water, and then I'm going to put it back in distilled water, and it should be stored. And that is how it should be stored. Strong acid. What is a strong acid? When an acid dissolves in H2O, a proton is transferred to the water to produce the hydronium ion. For example, the acid plus the water dissociates into the hydronium ion and an acidic ion. Well, for an acid to fully dissociate, it must be a strong acid. Because strong acids are so good at giving away an H plus ion, we can think of them as the reaction as being one way. For example, the water plus HCl, hydrochloric acid, completely dissociates to produce a hydronium ion and the chloride ion. Well, the strong acid is 100% ionized.
Alright, so weak acid does not fully ionize in H2O. For example, we have acetic acid here reacting in water. It produces an acetate and a hydronium ion. And for these reactions in equilibrium, the reverse reaction is actually more successful than the forward. And at any one time, really only 1% of the acid molecules are ionized. So where do solids and liquids go? Writing a Ka expression? Challenge accepted. Well, the solids and liquids do not affect the reaction amount at equilibrium, so their actions are counted as like 1, and they are disregarded. So for example, say we have 2A solid plus 2B aqueous yields C liquid plus 3D aqueous. So our K expression generally would be reactants over products, and we would have CD cubed over A squared B squared. So since A is a solid and C is a liquid, they're going to be 1. So that's saying like 1 times D cubed over 1 squared times B squared. So our final equilibrium K expression is going to be D cubed over B squared. Get to 27.4.
7.65.